There's something profoundly humbling about looking up at the night sky. Beyond the clouds, beyond the blue haze of our own atmosphere, lies a universe so vast, so ancient, that our greatest imaginations often fail to grasp its scale. But imagine just for a moment that we could leave Earth behind, not in body but in vision. That we could peel away the distortion of our skies and look directly into the untouched depths of space. That's exactly what we did in 1990, when a telescope named Hubble was placed in orbit around our planet. It wasn't just a piece of machinery. It was a gift to humanity. A pair of eyes that would never blink, never sleep, and never look away. Eyes that would watch stars be born, galaxies collide, and black holes whisper their secrets into the void. In the early days it didn't look promising. After launch, scientists realized the telescope's main mirror was flawed. It couldn't focus properly. Billions of dollars, years of planning, and what we hoped would be our grandest journey into space, blurred. But humans don't give up. In 1993, astronauts boarded the Space Shuttle Endeavour and performed what would become one of the most daring and successful repair missions in space history. They didn't just fix Hubble, they unleashed it. And what followed was nothing short of miraculous. One by one, images began to arrive. Not just stars but sculptures of light. Not just galaxies but whirlpools of color and time. Nebulae like exploding flowers, thousands of light years wide. Supernova remnants glowing with the last breath of a star. Hubble wasn't just observing, it was revealing. And in doing so, it changed not only what we saw but how we felt. Suddenly the universe wasn't distant. It was intimate. It was ours. One of the earliest and most breathtaking images was that of the Pillars of Creation, taken in the Eagle Nebula. Towering columns of gas and dust, they stood like cosmic mountains, so massive they could stretch from Earth to the Sun dozens of times over. But what made them even more incredible wasn't their size. It was their role. Inside these dark columns, stars were forming. Hubble didn't just show us where stars lived. It showed us where they were born. Another iconic image came from the Orion Nebula, a glowing cloud of gas and newborn stars just 1,300 light-years away, a cosmic nursery visible even with backyard telescopes. But through Hubble's lens it transformed. It became a radiant tapestry, each star surrounded by a swirling disk of dust, potential solar systems in the making. We weren't just seeing pretty lights. We were seeing the building blocks of other Earths. But Hubble's gaze didn't stop at our galactic neighborhood. It looked further. Much further. In 1995, astronomers pointed it at a tiny dark patch of sky in the constellation Ursa Major. A space so empty, it appeared to hold nothing at all. What Hubble found there was staggering. Thousands upon thousands of galaxies. Each one teeming with billions of stars. And all of it in an area no larger than a grain of sand held at arm's length. This image, known as the Hubble Deep Field, rewrote our understanding of the cosmos. It told us that the universe wasn't just vast, it was overflowing. And yet, these pictures didn't come through in full color. The universe doesn't arrive to us in perfect palettes. Hubble uses sensors that detect light in various wavelengths, some visible, some invisible. Ultraviolet, infrared, X-rays. These signals are then assigned colors so we can see them. In a way, Hubble's images are artistic translations, real data rendered into visible wonder. But make no mistake, what you're seeing is truth. Every swirl of purple, every glow of orange, every icy blue spiral, it all has meaning. And every pixel carries the weight of hundreds of millions of years. One of Hubble's most emotional contributions came not from a distant galaxy, but from our own solar system. When comet Shoemaker-Levy 9 slammed into Jupiter in 1994, Hubble watched. It captured the moment of impact, the scars left on the gas giant's swirling clouds. It was a reminder that our solar system is still an active, sometimes violent place. And it raised awareness on Earth about the real danger of future impacts, sparking new programs for planetary defense. Closer still, Hubble gave us unprecedented views of Mars, Saturn, Uranus, and Neptune. It tracked massive dust storms on the red planet. It revealed auroras dancing over Saturn's poles. And it even watched Neptune's storms vanish and reappear, like ghosts swirling in blue silence. It did all this from 340 miles above Earth, without ever leaving orbit. And then there were the supernovae. The violent ends of stars, caught in the act of their final explosions. Hubble caught the afterglow, the spreading rings of gas and debris. But even more importantly, it used those events to measure cosmic distances. In doing so, it helped refine our estimate of the universe's age, now placed around 13.8 billion years. Not just a number but a timescale that stretches back to the dawn of everything. Hubble wasn't just capturing images, it was writing a biography of existence. But perhaps the most mind-bending observations of all were of gravitational lensing. This phenomenon, predicted by Einstein, occurs when massive objects like galaxy clusters bend space itself, magnifying and warping the light of even more distant galaxies behind them. Hubble saw this. And in doing so, it gave us glimpses of galaxies so remote, their light left them when Earth itself had not yet formed. We weren't just looking far, we were looking back in time. And time was something Hubble itself had begun to beat. Year after year, its instruments were upgraded, its mission extended. What was supposed to last just 15 years has now continued for more than 3 decades. Hubble has seen 5 servicing missions, each one enhancing its capabilities. New cameras, sharper lenses, more sensitive detectors. Like an aging but ever sharper eye, it kept looking deeper and longer than we ever thought possible. But through all of this, perhaps Hubble's greatest accomplishment wasn't scientific. It was emotional. It inspired. Its images were not just published in journals, they were printed on classroom walls, bedroom posters, news headlines. They showed humanity what was out there. And in doing so, they reminded us of who we are. A species driven to explore, to ask, to seek, and above all, to wonder. Because every time Hubble clicked its shutter, it invited us to dream. And that dream is still unfolding. Even as the years rolled by, the Hubble Space Telescope remained undeterred in its mission, its metallic body orbiting Earth silently, tirelessly, like a vigilant guardian of the stars. It became more than just an instrument of science. It became a companion to human curiosity, a testament to what our species could accomplish when we reached out beyond our own world. From its stable perch in low Earth orbit, it kept watching, kept collecting light that had traveled unimaginable distances. And it kept turning that light into messages we could understand, images that could stir the soul, data that could reshape what we thought we knew about everything. Among the most captivating of its achievements were the time-lapse studies, Hubble's gift of motion across stillness. It watched stars wobble in place, hinting at unseen exoplanets tugging gently on their parent suns. It followed jets of matter streaming from young stars like cosmic beacons, tracking how these glowing tendrils evolved over years. It revealed that the universe, while ancient and slow, is also alive, moving, changing, pulsing with energy. It gave us the sensation that the cosmos was breathing, and we were finally close enough to hear it exhale. One of Hubble's greatest contributions to our understanding of the cosmos came in the form of dark energy, an invisible force pushing galaxies apart, accelerating the expansion of the universe itself. Hubble helped detect this force not by observing what we could see, but by calculating how light from distant supernovae stretched and dimmed in ways that defied our earlier models. It suggested that the universe was not only getting larger but doing so faster and faster. And no one saw it coming. It was a moment that left scientists speechless, not in confusion but in awe. We had thought the cosmos was decelerating, winding down. But Hubble told us the opposite. It was speeding up, running from itself, driven by a force we still do not fully understand. And just like that, we were reminded, we know less than we think. And the truth is even more wondrous. Its images of galaxies continue to astonish, not only in quantity but in intimacy. We saw spiral galaxies curling like frozen hurricanes, elliptical giants glowing with ancient starlight, and dwarf galaxies, tiny, chaotic islands of gas and stars on the edge of existence. Each one a city of suns. Each one a living archive of cosmic history. Hubble let us peer into galactic collisions, moments of staggering violence and beauty. 2 galaxies merging, their arms twisted by gravity, stars thrown across light years like sparks from a bonfire. And yet, from this chaos came the birth of new stars. Hubble showed us that destruction could be creative. That in the universe, even catastrophe could lead to light. And the detail, it was overwhelming. In the spiral galaxy M51, also known as the Whirlpool Galaxy, Hubble captured glowing lanes of dust interwoven with blue clusters of young stars and bright pink knots of hydrogen gas. Regions where stars were being born in a cosmic nursery so vivid, it felt unreal. But it was real. That was the beauty. This wasn't fantasy. This was the universe exactly as it is, simply beyond our everyday view. But Hubble didn't just look outward. Sometimes, it turned its gaze inward, to phenomena happening within our own cosmic neighborhood. It observed auroras on the outer planets, vast curtains of light shimmering over the poles of Jupiter and Saturn, created as solar winds slammed into their magnetic fields. It watched moons pass in front of planets, casting shadows over their colorful atmospheres. It even studied Pluto, capturing a world so distant and small that until Hubble's images arrived, we had barely seen it at all. And then there it was, A tiny icy world with surface variations with hints of geology and atmosphere, and a moon that danced tightly in orbit beside it. One of the most breathtaking applications of Hubble's power came with its role in supporting planetary missions. When NASA's New Horizons spacecraft approached Pluto in 2015, it was Hubble that had first mapped the surface. When the Juno mission headed for Jupiter, Hubble helped track storms across its surface so scientists could plan where to study. And when the Cassini mission neared its end at Saturn, Hubble stood back and watched from afar, its viewpoint giving us one final, sweeping perspective of the ringed planet. The telescope had become a silent partner in nearly every major planetary mission of the last 30 years. And then there was the Lagoon Nebula, a massive cloud of gas and dust where stars were being forged in the depths of space. Hubble's close-up image of this region revealed a breathtaking wall of interstellar dust, pierced by newborn stars that had carved out glowing cavities with their intense radiation. It looked like a seascape of stars, waves of color and texture frozen in space and time, and yet so vividly alive that one could almost feel the heat. The Crab Nebula, the remnant of a supernova first seen on Earth nearly 1,000 years ago, was another example. Hubble's detailed photos showed a tangled web of filaments expanding outward from a dense central star, what's known as a neutron star or pulsar, spinning hundreds of times per second. This wasn't just a light show. It was the corpse of a star, still humming with energy, still altering the space around it. Hubble didn't just photograph it. It documented its heartbeat. But perhaps no image sparked more imagination than the ultra-deep field, a successor to the original deep field. This time, Hubble stared into an even smaller region of sky for even longer. And again it found galaxies. Not hundreds, not thousands, but over 10,000. Some of them so faint they had never been seen before. Their light had been traveling for more than 13 billion years. We were looking at the universe as it was shortly after the Big Bang, the furthest back we had ever seen. And still, that image was just a sliver of the sky. Like a single drop from an ocean so vast, it made you feel small, but in the best possible way. It made you feel part of something enormous. It's hard to explain what happens to the human mind when it sees these images. They're not just scientific. They're emotional, philosophical, spiritual. They make you ask questions that science alone cannot answer. What does it mean to be here now in a universe this wide? Are we alone? Have others seen these stars? Will we ever meet them? Or are we simply passengers, gifted with eyes and minds and a fragile planet, granted a brief chance to look outward before the lights go dim? Even now, as new instruments like the James Webb Space Telescope begin their own missions, Hubble remains vital. Its partnership with Webb isn't a handoff, it's a collaboration. Where Webb sees an infrared, Hubble sees invisible and ultraviolet light. Together they offer a more complete portrait of the cosmos. One telescope peering into the hidden warmth of the early universe, the other capturing its brilliant glow. Side by side they are writing the next chapter of space exploration. And Hubble continues to surprise. Even in recent years, it has captured images of galaxies with unusual shapes, black holes at the centers of galaxies spitting out jets of particles across thousands of light years, and exoplanets with atmospheres that contain water vapor and strange chemical signatures. It's even helped track the movement of asteroids and comets, watching them tumble through space like lost fragments of forgotten worlds. As of today, Hubble has made well over 1 million observations. It has been the source for over 18,000 peer-reviewed scientific papers. It has rewritten textbooks. It has inspired documentaries, novels, classrooms, careers. And perhaps most importantly, it has inspired hope. Because in a world often defined by borders and divisions, Hubble reminded us of something bigger. That we all live under the same stars. That curiosity belongs to no single nation. And that when we look up, we do so together. It might be easy to think of Hubble as just a machine. But if you listen closely, it has a voice. Not of metal, not of gears, but of wonder. It speaks through its images, through the silence between galaxies, through the light of a star that died long before Earth was formed. It tells us, look, see, understand. And so we do. We stare into those images, those luminous storms of gas, those spirals of stars, those tendrils of light snaking across the night. And in them we see ourselves. Not because we are there, but because we can comprehend them. Because we can appreciate them. Because we can feel awe. This is the true power of the Hubble Space Telescope. Not just that it sees far, but that it makes us feel deeply. That it transforms cold space into a canvas of emotion. That it bridges science and soul. And long after it has stopped taking pictures, long after its instruments fall silent, its legacy will live on. In the minds of every child who looks up at the sky and wonders, in the hearts of those who dare to explore. And in the history of a species that once built a telescope, launched it into orbit, and with it, looked back at the universe and whispered, "Thank you."